Hello, this is James Borkman, Daniel Schindel, Ariel Mekis, and Getsemani Rodriguez of Section 7. Our heat exchanger roughly follows the design of a classic shell and tube heat exchanger. The hot water flows through the copper pipes on the inside, while the cold water flows across the copper pipes through the Tupperware container. The exterior of our heat exchanger is a 11.05 by 7.6 by 3.8 inch Tupperware container. The cold water flows directly through the Tupperware, entering and exiting through 1/2 inch bulkhead fittings. The hot water similarly enters and exits through 1/2 inch bulkhead fittings, but inside it passes through 3/8 inch copper tubing. To split the copper tubing, we use two Y splitters, also of 3/8 inch inner diameter. In order to connect the 1/2 inch pipe to the 3/8 inch Y splitters, we use two diameter converters. To manufacture our heat exchanger, we first drilled 1/2 inch holes in the exterior to insert the bulkhead fittings. To do this, we just used a hand drill. For the interior, we first bent the 3/8 inch copper tubing into the shape you see now, the kind of S shape, using a pipe bender. Then we soldered the Y splitters to the copper pipe, and then we soldered the other end of the Y splitters to our converters, which took the flow from 1/2 inch to 3/8 inch. Finally, we screwed the interior component directly into the bulkhead fittings, completing our assembly.
After the first test, we laser cut and installed baffles as shown in the picture. These baffles work as intended, as you can see in the bubbles traveling in the path we defined. We also added sealant to all the bulkhead fittings as well as around the edge, as well as duct tape to hold the lid down, preventing most of the leakage that was previously occurring. There's a negligible amount of leakage occurring in the top right corner. As shown in the video, the second test was successful.
The predicted figure of Merit 1 was 313.15 watts.
The calculated figures of merit are summarized below in a table. For the first figure of merit, we got 482 watts. For the second, we got 113,000 watts per meters cubed. For the third, we got 389 watts per kilogram. For the fourth, we got 831 watts per kPa. And for the fifth, we got 3.89 watts per US dollar.